it automatically starts. Okay, I don't even know if the volume works on this thing. So hopefully there's a microphone somewhere here with those kids at home. Okay. This is going to start off so basic that don't think that you're being that we think you're stupid. Okay, so this is like 5th and 6th grade math for just a second. Then it gets into stuff that's higher level in the next chapter. Okay, so this whole thing is rounding. This for hopefully you know how to round numbers, right? 5 or more, go next door. 4 or less, home is less. Home is best. Okay, so there's that if you need it. Here's what we do. So these packets are thick, but sometimes we go through them really quickly. Okay, so your friend go to the cafe for lunch, and you're going to kind of estimate the meal. Okay, and it says round the cost of each item to the nearest dollar and then obtain an estimate. You can use a calculator in this class. So people put this in a calculator and get the exact answer. They type it in their computer and they get the answer wrong because they don't want the right answer. They want the estimated answer. So you go to the meal and the soup was $3, right? And tomato juice for $2.25, so that's just $2. It will tell you where to round off to. Okay, so it's going to be pretty easy. Roast beef sandwich was $6, $5.60 goes up. Chicken salad for $5. 2 coffees totaling $3. Apple pie for $3. Chocolate cake for $4. Okay, and so then we're just going to add up all these estimates. 5, 11, 16, 19, 22, $26. Okay, $26. The actual was $29.85. Is 26 too far away from $29.85? Not really. Yeah. Some people might think it is. Probably not. We rounded down on a bunch of them, and I always, when I round, I always think, oh, well, I've been rounding down a lot. I think I'll round one up, and I'll offset it. So, okay. So, everybody in the classroom good with that? Good. This is so weird. Okay. Do we need to do another example? Are we good? We're good? Okay. So, you'll do enough of your homework. Second thing about your homework will be more difficult than the tests. Okay? So they don't want us to test at super high level. We don't have time for that, and that's not really the homework's to try to push you a little bit beyond your comfort zone. So you might now on this one you're not going to find anything difficult. Okay? So that's objective 1 of chapter 1.1. Okay. Well, let me make sure I do this correctly. I don't want to go too far. There's really just one lesson, I think, in this thing. I have to go look. Okay, so the next thing is a bunch of graphs that, once again, you've used some circle graphs or pie charts. You've used those before. Bar graphs you've used, line graphs. The important thing here is line graphs are usually over time. Okay, so the one that you'll see a lot of is global warming. Okay, so they'll go back to 1850, 1900, 1950, 2000, and then they'll make a prediction about 2050, and they'll say, oh, it's getting hotter. See, it's getting hotter. Okay. Well, it could be that there's just more people where they measure the temperature. Anyway, so a line graph. Here we're going to look at some, and then they'll just ask questions about the line graph. I have never had a student find that these are difficult. Never had a question about it. Somebody's like, I couldn't get number 7 on my homework. So If you can't get a question on homework, let me know. I can either make a video of it, or we can do it in class, or come in during your tutorial period or whatever. Okay, so all kinds of good questions off of a graph. So what's the estimate of people, college kids who smoke cigarettes in 2010? What is this? Every 4 years is a tick mark, so that's 2010. So you come bring it over here. I got about 18%. Is that what you guys had? Would you agree with that? 18%? All right. What 4-year period did the percentage of college students who smoked decrease at the greatest level? So that would be the biggest downward trend. Wouldn't it be right here? I think that's where it's went down the most in 4 years. So from 2002 to 2006. Pretty simple stuff. Which year to 30%? So we come over here to 30%. We come across. Looks like it's 1998. I remember when Weatherford College allowed the kids to smoke on campus, and we'd go over there. Man alive, they'd like to smoke. Oh, there's the answers. Did we get them right? Yes, we did. Okay. This one's referring to something we don't have, so I'm not worried about it. Oh, those are easy. Those are easy to do. Okay. And then the last part of this very first lesson is stuff that you've done all your life, making a formula for situations, and that's basically a slope. We're going to look at slope and slope intercept. What's it called? Whatever that thing is called, mx plus b. Slope intercept form? Okay. And the other one that you might need in this class is, just a reminder, is the point slope formula. And that is y minus y1 is equal to mx minus x1. Once again, not I don't know. Hopefully you've used this enough sometime in your life that that's not totally new. All right, so here's what it's going to look like. And I can also tell you this is actually on the final. The very final test that we take. This question is, or something just like that, is on the test. So they show you a graph, okay? And they want you to find the yearly increase in tuition. So basically they want you to find the slope of this. That's it. So remember, slope, m, is change in y over change in x. So I'm gonna come over here where there's actually some room. Change in y over change in x. Now, my class that went through this last time kind of switched that up sometimes. Some kids did. Be careful. Just when you're done, make sure your answer makes sense. Okay, so I'm going to go here, and I'm going to go from, I'm going to use these 2 points, the biggest and the smallest. They want you to use the biggest and smallest. You could technically use any 2 points, but the way that this is set up so that you get full credit, that you use the 2 endpoints. So my y's change from 33,480 minus 15,518, and my x's changed from 2016 to 2000. Okay. This is when you grab a calculator. You're more than welcome to use calculators in my room. However, I'm not sure exactly how to do that, because anyway, use this one. So 33480 minus 15518 is equal to that. Divide that by 16, and I get 1122.625, which is 1123. Per year. Okay. Make sure this makes sense. If you had these switched, your answer would come out to be if you had them switched, it'd be 0.00089. All right. So you'd have to recognize that that's a very small number for this. College is good, more expensive. So that's not it. But college goes up about $1,000 per year, which is it's a lot. Okay, so if it costs $10,000 to go to college this year, next year it'll be $11,000. That's why for college is so great, because you get your hours a whole lot cheaper. Okay, so that is number A. It says write the model for it. Okay, remember on ours we started at the year 2000, so that's why they're going to say that that's the y-axis. So they say since 2000. So all we have to do is go y is equal to the slope, which is 1123 times x plus how much it was in the year 2000, 15,518. Now if that looks bad, so I would say like this: tuition is equal to 1123 times, you don't have to do this, years since 2000 plus 15,518. So that's a little better. Tuition is going to cost me 1,123 times how many years it's been since 2000, so 21 times that plus that. And that's actually fairly reasonable. It's a little high. Okay? So what is it going to be in the year 2020? So then you just put in t years is equal to 20. So we're going to substitute 20 in here, and we're going to use our calculator. So tuition in the year 2020 will be 1123 times 20 plus 15,518. I'm going fairly quickly because I'm thinking that you guys know how to do Algebra 1. And I get $37,978. And if you went to UT, that's about what it would cost you to go for a year. But that's not tuition. Oh, this is just tuition, isn't it? This is at private schools, yeah. That's about TCU. That's probably really accurate for TCU tuition. And they give lots of scholarships and stuff, but that's the closest private school that we have. And with that, that's the end of 1.2. And there's a homework attached to that. So I'm going to stop the video.